And next up we'll be hearing from Ismael Pérez, looking for some synergies with some of the space-based missions, specifically Herschel, but it sounds like maybe we'll also hear something about Spica.
Okay, thank you. So thanks a lot to Jose Miguel, particularly for inviting me to give this talk, to try to find synergies between ground-based mid-infrared and space mid and far-infrared observations. So I'm part of this. Okay. I'm part of these two teams, one of the instrument teams on Herschel, Spire, and also on this Safari is the European consortium planning to build one of the instruments of Spica. I will tell you later for this Spica. So I will start with the conclusions in case somebody has to run. So conclusion, CanariCam, best possible angular resolution from the ground, also from space until we have space interferometers. Polarimetry, we have heard a lot about that. Rather good limiting fluxes for ground-based observations. On the other hand, Herschel and other infrared space telescopes, very good limiting fluxes, but very poor in general angular resolution. Full coverage of the mid-infrared and of the mid and far-infrared. Very high mapping speeds, large samples. Okay, so it's quite different, but complementary, I think. And if we look in detail at the approved Herschel key projects and at your guaranteed time CanariCam projects, there is some overlap. For instance, in galaxies, we have a project doing very nearby galaxies, and those galaxies are part of your samples that you will observe with CanariCam. So, and the other conclusion is Spitzer and Herschel and other telescopes who have already done an all-sky survey, a new all-sky survey, the Japanese Akari telescope and the near-future WISE telescope will provide huge, very huge databases of infrared sources from where we can choose the best CanariCam targets. So, and now really what I'm going to talk about is the review of infrared space observatories, past, present, future. Again, a summary about what CanariCam can provide in comparison with the capabilities of space telescopes. A few words about what can be done with Herschel, the observing capabilities of Herschel, what are the key projects that have been already approved, and a bit of publicity about this new mission proposed both to ESA and to Japanese Space Agency called Spica, and particularly the far-infrared instrument on Spica, the European contribution. And finally, what's going to happen next week? All-sky infrared surveys. We have already IRAS, of course, which has been very, very successful mission. We have Akari, not yet released, but this year there will be the first public release of the Akari All-Sky Survey. Not as sensitive as expected, but much better resolution than IRAS. So very, very useful, I think, as well. This year, WISE will be launched, and WISE, we discussed a bit about this before, is doing an all-sky survey in these 4 bands, 3.3, 4.7, 12, and 23. So this is, I think, the mission that is most important with regard to CanariCam, because it will cover the wavelengths where CanariCam works. And from the ground, we have obviously 2 masks, but this year also Vista is starting operations, and one of the surveys is covering the whole southern hemisphere, so the DHS survey. And these are not all sky, but are very large area surveys. So very large area surveys have been done with Spitzer and will be done soon with Herschel, including an extragalactic survey like Herschel Atlas and similar one in the galactic plane, High-Gal, covering 600 to 700 square degrees, very many sources. So 6 months to the WISE launch. The 40-centimeter telescope will provide an all-sky survey from 3.3 to 23 micron, up to 1,000 times more sensitive than the IRAS survey. This figure shows the sensitivity limits. So this is IRAS here and ACARI, AstroF, while WISE is down there. I mean, 1,000 times more sensitive than IRAS. This is important in respect to SPICA. In all these surveys, there is a gap between 25 and 60 micron, which has not been observed by any mission. And we are trying to fill this gap with SPICA because it's very interesting wavelength range. Well, basically to pick up the PAH features and silicate features at a higher redshifts than IRS on Spitzer has been able to observe. If you think about deep fields, I mean, we have had many observations, but by ISO first, then Spitzer, then ACARI, and in the coming futures with Herschel and JWST in many different bands, again with a gap between 25 and 70 microns. So again, the comparison between CanariCam and space telescopes, the unique features of CanariCam are the sub-arc-second, very high angular resolution, 0.2 arc-seconds, polarimetry. In general, the space infrared instruments do not have any polarimetry capabilities, so I think this is very important. Rather good limiting fluxes compared with other mid-infrared instruments on the ground, and that facilitates, I think, studies of not just the low redshift objects, as Almudena has already described, but also the possibility to extend those studies to very high redshifts. But very small field of view, spectral range limited to the atmospheric windows. On the other hand, space telescopes, they provide a much wider spectral coverage, near infrared to 7 millimeter, very low background, no atmospheric absorption, very good limiting fluxes, very large field of view, very large samples. And as an example, I put here last year we published the Swire Photo C catalog, and it contains more than 1 million infrared selected galaxies, but very poor angular resolution. So as an example, I have put here a couple of figures about our study of relatively high redshift, sources selected from ISO LA survey and also included in the Swire survey. And here you see some examples of these sources observed with IRS on Spitzer from 5 to 35 micron. This is a mixture of AGN and star-forming galaxies. Star-forming galaxies show clearly PAH features, silicate absorption, etc. And some of these sources are bright enough for observations with CanariCam. So we are planning a proposal for next semester, whenever CanariCam becomes available, to do these sources like this. At the redshift 1, the resolution of CanariCam will correspond to 1.6 kiloparsec. So it is not extremely high angular resolution projected on the source, but still interesting enough to image and maybe also spectroscopy of these high redshift objects. And this is a summary of the composite spectra of these objects. Type 1 AGN, nearly featureless. Type 2 AGN, they show silicate absorption and PAH emission, and the starbursts are clearly similar to what Almudena showed earlier. Okay, a few words about Herschel. Herschel has 3 instruments, PAX, Spire, and HiFi. They provide very good imaging capabilities, including a parallel mode, that you can use the 2 instruments at the same time, PAX and Spire. It also has very good spectroscopic capabilities with the 3 instruments, going from low resolution to very high spectral resolution with high HiFi. But it's a warm telescope, so it's not cool to the cold temperatures of, for instance, Spitzer. So a cold Herschel would be much better than the current Herschel. So that's what we are planning to do in the next decade with Spica. I'm not going to discuss in much detail all the instruments, but basically both PAX and Spire have imaging and spectroscopic capabilities. So here you have the imaging mode of PAX, simultaneous observations in 2 bands, out of 3. Point source detection limits on the order of the millijansky, a few millijansky, 5 sigma 1 hour. Spectroscopy using an integral field unit with resolutions of 1,000 to 5,000. Point source line sensitivity of around, well, a few times 10 to the minus 18 watts per square meter. Spire is also 2 sub-instruments, an imaging photometer and an imaging Fourier transform spectrometer. Here in the photometer you observe simultaneously in 3 bands, 250, 350, 500 micron, with point source flux limits of about a few millijansky in 7-point mode. I mean, if you do just 1 source at a time, and also very good sensitivity for maps. And in the spectroscopy is not that good because it uses an FTS, so it covers the full spectral range, but not very high sensitivity. And the other extreme is HiFi, the heterodyne instrument. In this case, there is no imaging capability. It's just 1 point on the sky, but at resolutions going up to 10 to the 7. So you're interested in very high spectral resolution, so this is the best instrument on Herschel. So what's Herschel going to do? A large fraction of Herschel time has already been allocated to the so-called key projects, and by definition is the smallest amount of time on Herschel at the moment is 100 hours. So all these are very large programs. They first allocated their guaranteed time, basically the instrument team's own time, and afterwards they allocated open time to many other key projects. You can look at the list of key projects and abstracts. I don't have time to discuss this in detail, but you can go here to the Herschel Science Center and look at the list of abstracts. If you're interested to know if a particular source you're interested in, if it is in the Herschel key projects list, you can use the Herschel Spot software. It's similar to Spitzer Spot, and then you can find if a particular source is going to be observed and in which observing mode, etc. As I mentioned before, I had a look at the plans of the CanariCam team, and I noticed already some months ago that we have in common some objects that you are planning to observe with CanariCam, and we are planning to observe with Herschel in some of the guaranteed time projects. So the next step, maybe 10 years from now, or maybe less, or maybe never will happen, I don't know. So it's this called Herschel, SPICA, Space Infrared Telescope for Cosmology and Astrophysics. This is a proposed joint Japanese ESA mid-infrared and far-infrared mission for the late 10s. And it's part, in Europe, this is a proposal to the Cosmic Vision, one of the proposed missions that was selected for further study. And this year we have another down selection, and we hope to continue, because it is relatively cheap compared with other missions, and there is a good opportunity for ESA to continue the expertise gained with the Herschel telescope in another mission and going to cooler temperatures. So an overview of this mission is a 3.5 meter mirror, actively cooled to less than 5K. So using mechanical coolers, is not using cryogen. It extends the Herschel spectral range to much shorter wavelengths, so it overlaps with JWST, so it starts at 5 micron and goes up to 210. This is the core spectral range. It could extend to the sub-millimeter as well. Resolutions nearly as good as JWST at the shorter wavelengths. So 0.3, comparable to CanariCam, and going up to 14 arcseconds at the long wavelengths. Similar orbit as Herschel and Planck L2. The launch, this is a warm launch. It will cool in orbit. As I said, cryogen free, so that means a long mission lifetime of over 5 years is possible. Optimistic launch date 2017. Observatory class mission, so with observing programs open to all astronomers in all member countries. And this is the instrument suite of Spica. Japan is planning to contribute with the middle-infrared coronagraph. The main science is the direct detection and spectroscopy of Jupiter-like exoplanets. 10 to the 6 contrast, operating wavelength 5 to 27 micron, resolution small 200, field of view of 1 by 1 minute. Then a middle-infrared camera and spectrometer in the wavelength range 5 to 40 micron, with a field of view of about 6 a minute, with spectroscopic capability with an integral field unit going from 3,000 to, well, maybe as large as 30,000, maybe less. And the European contribution is this instrument called Safari, a Spica for infrared instrument, and maybe this is being considered that the US contribute with a sub-millimeter instrument as well. A couple of words about Safari. Safari is, you could think of a copy of Spire on Herschel. It's an imaging Fourier transform spectrometer with instantaneous wavelength coverage 35 to 200 microns. So it's, let's say, the PAX wavelengths, but with the Spire technique. A field of view of 2 by 2 minutes, with several spectral resolution modes from very low resolution in photometry to high resolution 2000. And the particular capability of this instrument is the sensitivity to lines, to faint lines. So sensitivities of 2 times 10 to the minus 19 watts per square meter, 5 sigma, 1 hour, and very good continuous sensitivity as well, below 100 microjansky or even 50 microjansky. Conclusions. 2009 should be the International Year of Infrared Astronomy. So we have first light of CanariCam, launch of Herschel and Planck next week, first release of Akari All-Sky Survey, end of this year, launch of WISE, end of this year, continuation of Spitzer and Akari in the warm phases. Particularly Spitzer is doing very large programs, only at two wavelengths, 3.6 and 4.5, but very powerful at those wavelengths. And hopefully, selection of Spica for next study phase. And finally, what's going to happen next week? Next week is very, historically, a really important week in astronomy. So we have finally the HST servicing mission on Monday. The shuttle is launched on Monday. And hopefully, if there are no more delays, on Thursday, ESA will launch from Guyana, Herschel and Planck together. You can follow the launch live on the internet at this Arianespace website. And you can go to this Herschel Science Center website and also look at how many days and hours, seconds still remaining for about lunchtime on Thursday. There are no more delays. This will happen, hopefully. Okay, thanks a lot.
So, something to look forward to for next week. Questions?
One comment. In addition to the key project that you have mentioned, related professor, there are at least, as far as I know, 2 approved key projects in Herschel where people of the CanariCam science team are involved. One is dunes. Dunes means dust around nearby stars, and the second one is gaps, and gaps means gas into the planetary system.
I'd like to listen to your opinion about Spica. What is your opinion about if it's going to, if it has good chances to be selected, and if not, what's going to happen?
The answer is of course. There is, all the instrument teams of Herschel are together, I mean, proposing a speaker, and ESA is interested, and it's cheap compared with the other missions. So the original rules were, ESA was looking for a medium-sized mission, and medium-sized means 300 million euros, and it was looking for a large mission, and large means 650 something million euros. But then they realized that the large missions were not, I mean, the technology is not there, not even in the next 10 years. So they decided to use, I think, if I understood it correctly, to use the whole money for probably two medium-sized missions. And that's what we are competing at the moment for. But they put also solar orbiter in the same box, so it's a bit complicated. Jesus Martin is very informed about all this, so maybe he has another.
ESA has a very close collaboration, and ESA is willing to sort of deliver the telescope, which is basically a heritage from Herschel. So I think if we are able to convince that our team is able to build Safari, I think we'll have very large chances to get selected in the next round. Basically beginning next year, but starting the process starts at the end of this year. So beginning next year, we'll start.
This is sort of, it costs less than 200. So these guys handling this in different ways than in that mission. So we don't know how this is going to be handled. But it's not really a medium-sized mission, but
that will work between 35 and 200 microns, and we have to remind that niche, that gap of wavelength won't be covered by any future mission. That is being ready for 18 million, and that's why ESA decided to get Spica out of a medium-sized mission and call it a mission of opportunity. Because you take basically the mirror you've done for Herschel and produce a second one, so you do all the get all this heritage, and then the Japanese will do the cooling and the rest, and the European instrument, which is Safari, has been so far by the Japanese as a core instrument of the mission. 80 million is for ESA contribution, ESA pure contribution, 80 million for the European instrument, which is has to be funded by the national agencies, not by ESA. Okay.
Other questions? Charlie, I know, had a comment before then we shift gears into, we've got room for another discussion session here, but Charlie,
Sure, yeah. I just wanted to add my thanks to Jose Miguel and to Nancy for organizing this very useful workshop. And as the CanariCam principal investigator, I think I can thank you on behalf of CanariCam. And, I certainly fully anticipate that a year from now, maybe under a year from now, we'll have a workshop dedicated to discussing the first results. And I think that will be very, very exciting. And so, again, thanks a lot. It's been very useful.
great. Well, Charlie, thank you for building it. As you can tell, there are a lot of people who are ready to go, ready to use it. So, opening the floor to more general discussion, more thinking about You know, Renee's here, give him your wish list. Charlie's here, give him your wish list about things. perfect images and all of that. I mean, what else do you need to do the science? What are the outstanding questions you have to be able to write those brilliant proposals and get those papers out instantaneously? Are there other comments on mid-infrared observations in general?
I don't know whether I should say this, but getting CanariCam data is of utmost importance for us politically. The reason is that very often the observatory is thought not to be adequate for mid-infrared astronomy. And although we have been making tests of water vapor and all that, and we think it is a reasonable size, we need to see the first data to prove it. And so I encourage everyone to submit proposal and get the data out as soon as possible.
Well, let me pick up the water vapor thing then, and this is really to Renee. So again, Gemini South bought a water vapor monitor. I think it was essentially off the shelf. I can put you in contact with those people. It was the guy who left it actually left. The guy who led that has now left Gemini. But I think there are the history's there. So if the money is around, then we can work together. Right. Yes. My belief is that it was essentially off the shelf, is my belief, but I was a bit distant from that.
So is the observatory responsible for telling us if the night was good? I mean, are you going to do like a, right away data reduction of those standards and tell us? Or is it up to the observer to tell you?
So let me just say that usually the procedure that we followed was at the very beginning of the night, just as you're starting when you open up and you're just getting ready to start observing, you go to a standard. It's really simple. So you take 10 microns, you take 20 microns, you take the ratio, that's it. No, you just use the raw numbers and the number that's fine. So it should be a big deal.
Right, but I think Alexander makes a good point that information has got to be passed to the PIs of this keyboard observing to be confident of yeah, exactly. More comments, questions?
I was wondering that if GTC have any plans to make a call for proposal using different instruments at the same time with the GTC. I mean, searching for synergy between CanariCam and Osiris or Emil when it's live. No, well, not at the same time, but I mean the some kind of key project that use the different instruments. Of course, you can. Yes, that's it. Yes, I think it would be very interesting to have some multi-frequency approach to this project.
Mode, that is the way we are mostly operating. You can specify time observation, like every month or every other month, whatever, and that's easy to accommodate in Q mode.
Any other thoughts?
I was a little bit taken aback, perhaps, by your comment that you're really pushing towards 100% Q mode observing. Did I misinterpret?
The first year of operation will be Q only, and I think also the first semester at least of CanariCam will be Q only as well, because we have to learn in the process. And having astronomers present in the control room can be a distraction, can be a help, but often is a distraction. We don't exclude astronomers from being there. If people want to come along for the ride, then that's fine. They can come, and people have been there present at the in the control room during observing already. But we have to limit it. We have to be careful that we don't distract the astronomers, the GrantiCam astronomers, the support astronomers, from actually taking the data and concentrating on the observing process, which is very complicated at the moment, as I said. I think in the long term, the idea is to have a healthy mix of Q and classical observing. We have to wait and see what is the best mix. The experience from other telescopes is 50-50. Is a reasonable mix, and that's probably what will also evolve in GrantiCam. The reason to start with Q observing is, particularly with CanariCam, you have to pick the right nights for the right signs. So that's a key reason. But operationally, the key reason is the complexity of observing at the moment in GrantiCam. So it's to protect ourselves.
I understand that. It would be if astronomers come along sort of at their own risk, as it were. In other words, they come along with the possibility that their objects won't be observed, or even it may not even be a mid-infrared night. I would still encourage you to encourage at least small teams, maybe 1 or 2 people. Obviously, more people than that can become somewhat confusing. But during the initial phases, it might be quite useful to have those people there. And also, it's appropriate for the real observers to see the real observing environment, because I do believe that it will influence the next generations of proposals that come in. Because one of the problems I think Gemini had in the early days, when we were using our Oscar instrument that commissioned Gemini, was that proposals were coming in that were incredibly unrealistic, and the proposals were not well defined, because the community who was proposing to use mid-IR, many of them had never done mid-IR before, and they didn't really have an appreciation for the constraints. And so, if there's I would just soften the idea about having only Q scheduling, and at least maybe offer the opportunity for people to be there, given, of course, that they have to follow appropriate protocol within the control room. That's quite reasonable.
I think it's a very useful comment, Charlie. We have to distinguish between the presence of astronomers, visiting astronomers in the control room, and the Q scheduling mode. There are 2 different aspects to it, and 2 different pluses and minuses that you have to take into account. As I said, we don't want to exclude visiting astronomers from the control room, but we have to make very sure that the astronomers, the GrantiCam astronomers, sport astronomers, can actually concentrate 100% on the observing process, rather than to be distracted from trying to connect people's laptops to the internet, for instance. we don't want.
So related to this, is there any discussion of having eavesdropping modes available so that the observers whose data are being taken, they can listen in, they can see what's happening in real time, but not necessarily be physically present?
No, we haven't thought about that particularly. And the accessibility of the mountaintop on La Palma compared to Hawaii, say, is quite easy. You can drive up in an hour and you're there.
I should say that in the case of solar system observations, solar system object observation, that has a lot of particularities because our object moves, and that means that the observers has to change mind. It's not simple. I have large discussions with support astronomers just because they want me to send a finding chart for a semester, and that's impossible. Okay. And the experience in other telescopes, for example, at VLT, is that Q observing of solar system objects are only allowed if observations are extremely simple. If you want to do a spectroscopy, you absolutely need an expert astronomer to do that. Just recognize the object in the field is not as recognize a faint object fixed in the sky. So for us, the fact that service observing is the only possibility is not good at all.
Actual situation for the reasons I just described, that the observing with GrantiCam, the simple activities that on a telescope which is stable and has been in operation for many years are trivial activities, on GrantiCam are not trivial activities yet. That's a key reason.
Some particular cases you should identify and allow some particular cases observations should be scheduled in particular nights and ask astronomers to be there. Otherwise, it will not to the problems, normal and natural problems of new telescopes that you have that can lower their efficiency. They are support astronomers that have not experience in observing this kind of object. I can imagine other kind of objects. There are observations that can happen the same with can look the efficiency much more. So
it's an option already, and it has happened already. So if you have a particular case in mind, and I guess there's one of your proposals, for instance, that you feel that you really have to be there, then you can come. But there's no guarantee. We cannot provide a guarantee that certain things will happen on a certain moment in time. For the complexity that I just described. But it's what you described is absolutely possible and has happened.
Thank you, Javier. Just to say, I agree with you that these observations are more difficult, but from my experience, I was super astronomer at ISA, at the IUE satellite, and many times we did this kind of observation of comets and non-sidereal objects, and we studied a lot each observation. I don't know how the GTC is going to observe, but we spend a lot of time preparing each observation. So, in collaboration, in very near collaboration with the PI. And I suppose that it will be the way to do at GrantiCam with this kind of observations.
Okay, if you can do that, then I'm sure this will be possible.
I guess if there is no more questions, I encourage you to, now that you have Charlie and Chris here, if there are any questions about CanariCam, just go ahead and talk to them. We have lunch prepared for 1:30. I don't know whether it's, I don't think it will be ready yet, but 1:30 should be there, and I encourage you to go to lunch because otherwise it's going to be spoiled. And finally, I would like to thank you for coming, and I hope you spread the word throughout the community that CanariCam is a wonderful instrument and there is a lot of science that can be tackled with CanariCam. Thank you very much.
Thank you, Jose Miguel. Actually, it's a pleasure to be here. There are a lot of things going on, and I didn't get so much sleep this time. So maybe this thing has been, sorry for repeating again, maybe this thing has been discussed already, but can you clarify a little bit better, can you guys clarify a little bit better how the proposals are going to, proposal submission and so on is going to be scheduled, and when and how and so, I mean, in terms of next actions, what's going to happen?
That is already established from many years. There is a time allocation committee, all the proposals go through that. Now that's different from scheduling. Scheduling depends on the observatory, and René is the head of operations. So.
I mean, for example, I know that some time of the GTC is going to be available through the ISO time. Is CanariCam included in this? Okay. So the proposal and the proposal deadline is going to be every 6 months or so. Once a year. Okay, so there's not going to be a call in October 1st or something. Okay, and for the other time is when? Next April and September.
I've got a question related to the fact that we don't have any L or M other facility to observe in the thermal infrared. How good would be the possibility to get also observations in the M band with because you said it was only in engineering mode, but how efficient is the telescope to work and get data also in the M filter?
Well, we do have K, L, and M in there. Yeah, but the traditional years, every other single observatory in the world has placed
Well, I'll come in on the availability or the applicability of CanariCam to operate at K, L, and M. The filters... Okay. Okay. So there is capability to do L and M, but I think Charlie would likely agree with me. It's not competitive. It's the efficiency of the array is very low at L and M. Charlie, do you have any?
I think the simple answer
Yeah, I guess so. No, I'm going to labour the point. I think it wouldn't be competitive with other instruments around the world. I guess because of the throughput of the, actually even the window, the Insular window, I don't think has a great throughput. I think the detector isn't great at that wavelength, and also we're still forced to chop and nod. So you're going to get that lack of efficiency, and the chop frequency is probably going to be defined at the 10 micron. So there's a lot of overheads.
But the bottom line is, if you want to use it in the objects of writing up, that's fine, you can do it. I mean, I don't know necessarily, I suppose in the normal proposal process, you include that. We haven't probably said anything in any of the literature supporting CanariCam on what we predict the sensitivity will be, but it's probably scalable, but I suspect it also to find out when we start doing it. And then you can put that in the proposal. Nevertheless, the fact that the filter's in there, if it sounds like you can make a special note or comment in the proposal that this would be useful, then No, we understand the point you're making. Yeah. Yeah. We hear you loud and clear.
It's fine if you want to keep talking, that's excellent, but use the microphone because otherwise people will not listen to you through the internet. What is the mic?
I said that the M phase back. I just reminded Paco that the M phase back will have a third and we'll have the M light filter.
Do you want to say anything? Okay, then.
I have a curiosity. It's mainly a curiosity. I think there are some, I heard that there are some improvement in detector technology for space application. They're building these silicon arsenide 1K by 1K. Why they are not used in ground-based?
They are. They're starting to use them. Yeah, they're starting to use them. The Vizier is being upgraded. Sorry. Our understanding that Vizier is being upgraded to a 1K by 1K. But when we had to select a detector for CanariCam, the 1Ks were not available. So that means, we started building it 6 years ago or something like that. Very certain. Today is more than that. So the 1Ks were only in people's imagination. So, and some people have asked us about retrofitting CanariCam. They could be retrofitted. The pixels are smaller, so the scale would have to be different. They would be vastly oversampled in that case, unless one then wanted to retrofit by changing all of the optics. But then you run into problems with vignetting at the input because the entrance hole is small. So it's not clear how effective a retrofit would work. The only gain that a retrofit would give you probably would be if the quantum efficiency of these new detectors is substantially greater. I actually don't know what the QE is. Then that might be worth it. But currently a retrofit doesn't look likely. But it's something that most people, once you have a system that is functioning well, you don't necessarily want to retrofit it with anything. But that's certainly something that we could discuss with the GTC down the line.
I don't care because we observe one light option.
Right. But if there's a big improvement in QE, then that might be worth changing.
I guess just to add to what Charlie was saying, this 1K detector, the Aquarius, it's not quite produced at this stage,
Additionally, it's my understanding that the so-called silicon multiplexer is fundamentally different. That would probably require not only some implications for optics, etc., it would require new electronics.
Oh, yeah,
and so we'd be beginning to, for a relatively simple change, the effects begin to grow and grow.
I think also the full capacity of the pixel is somewhat small.
Oh, sure. Yeah. Usually the space versions of these detectors are very low well compared to what we need. And so there's usually a ground-based high or medium well corresponding detector. We're current, I mean, the Raytheon detector as well as the Boeing detectors that Boeing was being used on the Vizier, the old version of Vizier. Those detectors are in fact ground-based, deep well ground-based versions of what were put into space. Something like, I think 10 to the fourth, maybe even 10 to the fourth electrons were the well depths for the low background ones, whereas we're talking 10 to this, up the order 10 to the sixth. So this is a big difference. So we couldn't just simply use the same detector.
In any case, let me change subject for a minute. One thing that is happening at Gemini, I understand, is that T-Rex is not used much. I don't know whether it's because there is more pressure for other instruments and not enough pressure for T-Rex, or for other reasons. What is your appreciation of the...
So I think, to be careful what I say, no, it's okay. I think, Jose Miguel, you're absolutely right. When we compare the mid-infrared instruments on Gemini to, say, optical or near-infrared, they don't get maybe as much as of time as those other instruments do. I think it's particularly true for Michel. That might indeed be because of time pressure on Gemini North. It's a packed telescope in the north, maybe more so than T-Rex in Gemini South. I think my personal opinion for Michel, which is the one that people worry about, is there's been some aspects of the observatory, so primarily the chopping secondary, that for 2 or 3 semesters, I think it was, degraded the image quality significantly. So it wasn't necessarily Michel's fault, but the result was Michel wasn't demanded very much. That's changed, and actually there's been some change in the amount of applications made, but still it will always be a fairly small draw of people. Samantha, do you want to?
No, I don't think I have much to add to that, except by virtue of the people who are in this room, at least potentially being mid-infrared, ground-based interested, when there's competition to put different instruments on a telescope, if the mid-IR observing community does not respond with proposals, then eventually those capabilities will go away in light of competition. So if you are interested in having these kinds of instruments maintained on large ground-based telescopes, then you also have to be using them.
And I think we are in a very good position because at GTC now we only have Osiris and CanariCam. Maybe when Emir comes online, there will be more competition for the near-infrared, but for the time being, CanariCam should be online as often as the weather permits.
So, Charlie, unless you have a comment on that, can I switch gears a little bit and appeal to René?
I heard that that was also the case for Vizier. So Vizier was not super oversubscribed because the instrument is not super good, it's not performing super good. And I think another reason for T-Rex and Vizier not being super oversubscribed is that because Spitzer was still around. So people, what should I do? Should I send a Spitzer proposal or should I do ground-based observation? Now that Spitzer has finished the cool mission, I think maybe some more people will submit proposal to ground-based telescopes.
I agree with that. I mean, I think a lot of people who might have used ground-based NIR use Spitzer, and I believe that is, in fact, the case, although people should realize that the ground-based telescopes have a lot better resolution than Spitzer. I think Almudena's talk demonstrated that nicely. I think a lot of people who have used mid-infrared maybe haven't really, their backgrounds are such that they didn't really necessarily think about the implications of angular resolution. They just thought sensitivity and thought Spitzer in that regard. I don't know enough about how the culture has worked against the mid-IR, and I've thought about it in some ways, but perhaps I missed some key points. But.
René, so switching gear a little bit. So whilst I recognize there's enormous amount of pressures and balances to be made running GrantaCam, it's nevertheless true to say that CanariCam would be optimally placed at the Cassegrain focus for all modes, but maybe particularly polarimetry and coronography due to the reduction in mirrors. So let me just make that comment, although I do recognize that there's weight issues on Naismith and Cassegrain that might drive CanariCam to remain on Naismith. But do you have any comments on how much we might expect CanariCam to be on CAS?
The current bottleneck in placing CanariCam at the Cassegrain focus, and because we recognize clearly the advantages of the Cassegrain focus, particularly for CanariCam, is the A&G infrastructure that you need, the acquisition and guiding infrastructure that you need to build there. It doesn't exist. It's not even being worked on. So we're talking about years. The priority in terms of the acquisition and guiding infrastructure is now the Naismith A focal station, where CanariCam will first go, then the broken Cassegrain focal stations, and the hope is that the infrastructure that's being developed for that will also go into the main Cassegrain focal station.
I think we better close this. Thank you very much.